Hi everyone. So as promised, we're going to shift gears a little bit and move from talking about life zones as a general concept or as a global phenomenon to looking a little bit more closely at some of the life zones that we find here in Colorado and particularly along the Northern Front Range. So we'll be spending quite a bit of this lecture and the next few looking a lot more closely at this chart and unpacking a lot of the different things that are going on here, looking both at the overall patterns and at some of the particular life zones and species that we see depicted here. Now, in our last lecture, I gave you guys a couple of slides that look a little bit more closely at the relationship between biogeography in general and this concept of life zones. Now, as you'll recall, we've defined ecosystems as bringing together a number of different factors, whether those are abiotic conditions or the particular species living in their habitats and niches, or at the relationships between those species. Now, there is a whole lot of different types of interaction going on, and in fact, a lot of these have influence on everything else. It's kind of like picking up one noodle out of a pile of spaghetti. You'll find that it's connected to just about everything else. Even so, we can start thinking about how abiotic conditions influence species and species influence the relationships between species, and ultimately those relationships between species end up feeding back and affecting abiotic conditions as well. However, we can boil a lot of that down and think about life zones, and particularly life zones as divided by altitude, as a nice shorthand or a summary for a lot of these complex relationships. A lot of the abiotic conditions that we see are heavily influenced by climate. Elevation affects climate in a predictable way, and therefore we can sort of say that elevation is the most important, or at least one of the most important factors in determining what species are going to be able to live in particular ecosystems and how they'll relate to one another. Of course, it helps out that a lot of these life zones also connect to pretty clearly visible changes in vegetation, even if, as we've seen, a lot of those lines tend to be pretty fuzzy when we look up close. So last time we spent a while looking at sort of the different forest types and some of the relationships between what elevations we would see tree line at, or upper tree line at different latitudes, as well as looking a little bit more closely at some of the distinctions that we see as we move from area where there are clearly trees growing to areas where there are clearly no trees growing. And you'll be exploring this in Lab 4 towards the end of this module. But our real goal in this lecture is to look a lot more closely at what's going on in our model of the Colorado Front Range. Now, I've already noted that this isn't necessarily a universal model. It's not as though there's some foreordained natural law that says that there's a clear division between the three life zones, and they shall be thus, the lower montane and the upper montane and the subalpine. Rather, we can think about this in a lot of ways as an attempt to take our description of what's going on at these different altitudes and try and tweak it for real-world conditions. So you'll see that there's a whole lot going on here beyond just sort of the layer cake that we've developed in past. Beyond just saying, well, there's a lower tree line and a forested zone and an upper tree line. In fact, you'll find that in Colorado, those tree lines both look a little bit fuzzy. And even if we start thinking about some of these subzones, there are in fact a lot of species that you'll find spanning across a number of different ones. So there's a lot going on here, and I'd like to take this lecture to kind of unpack this chart. In order to help you make sense of everything that's going on, I've given you a bit of a fill-in chart. And this kind of gives you a schematic to note down a lot of what we've seen in that chart, and to start understanding everything that's going on here. Now you'll note that there are several things that I've laid out, both in terms of these different columns. In particular, I've given you space to record the 6 major life zones that we're caring about, and within those 6, particularly the 3 that are forested. So the lower montane, the upper montane, and the subalpine. To remind yourself of where our 3 key lines are, the snow line, the upper tree line, the lower tree line, to look at the elevations that correspond to each, and then to do something a little bit more complex, which is to note that there are really 4 major forest communities that we're looking at. And these don't exactly line up with each life zone. If they lined up, it would be just too easy. But hopefully this gives you a chance to keep those a little bit more straight as we work through this. So I would really, really strongly urge you to print this chart out, and as we're working our way through these lectures, to actually fill this in and take notes. The process of writing it down for yourself, I think, is one of the better ways of cementing all of this into your mind. Now, we're talking about 4 major forest communities. And that's in fact a simplified view of what's really going on. If you were to ask the USGS, they would tell you that the Rocky Mountains have about 10 major forest ecosystems, and a couple more that exist beyond the forested zones. You can see them all listed out here: plains and riparian forests and all sorts of things. Now, many of these aren't really present in the northern Front Range of Colorado. I've italicized the ones that are. And this all of a sudden seems like a whole lot more to memorize, and it gets even more complex if we map it out. These being those 10 communities that I've italicized. Now, this looks maddeningly complex, but when you look at it a little bit more closely, you can start to see that there's some pattern to all of this. Namely, we do see a pretty strong effect of altitudinal zonation. So what this diagram is really trying to do for us is to get us thinking about how these different forest communities correspond to our system of altitudes, as well as a bunch of other stuff. And it's this other stuff that I'd really like to go over here. So we can start out with altitudinal zonation. And hopefully, if you take a look at this layer cake model that we've built up, you'll see some echoes of it in the more detailed model that we're trying to explore. In particular, the major zones and the major transitions that we've already discussed are still present here in our detailed model. You can see the 3 major zones of forested vegetation: the lower montane, the upper montane, and the subalpine. You can also see the major lines, the lower tree line and the upper tree line. Even though in this model we've sort of shifted from talking about lines to ecotones and drawn in a pretty broad area of transition between the grasslands of the plains and the ponderosa pine forests of the lower montane. We'll get a chance to see what that sort of lower ecotone environment looks like. And similarly, we could broaden out the upper tree line a little bit, though not quite as much and not necessarily spanning 1,000 vertical feet. This altitudinal zonation, however, is pretty important for a couple of reasons. Again, we're using altitude, or we're using elevation here, as a shorthand for climate. So as we look at our major zones, we see that they actually correspond both to a pretty clear distinction in terms of mean annual precipitation, and though this chart doesn't as clearly show it here, to a distinction in terms of temperature. So as we move upslope, we're dealing with greater precipitation and lower annual average temperatures. So here's a little bit of a cheat sheet going over some of the different elevations where this is taking place. Here in Colorado, upper tree line is probably about 11,500 feet. In some cases, you'll find that tree growth is restricted not just by climate, but also by soils. You're not going to find many trees growing, for instance, on bare rock. If we move downslope from the upper tree line, we'll come to a subalpine zone between about 9,000 and 11,500 feet, an upper montane zone between 7,500 and 9,500 feet, a lower montane zone between 6,000 and 8,000 feet, and a pretty broad lower ecotone between 5,000 and 6,500 feet. That lower ecotone is particularly subject to other forms of climate variation. Remember, the main driver of that isn't strictly based on temperature, but is instead based on moisture availability. So it's a lot harder to pin down a single elevation for lower tree line as it is for upper tree line. You'll also notice that as you look over these, there's quite a bit of overlap between each zone. We can see that if we look at it numerically here. Our chart also reflects that. So why is there this overlap? Well, one of the biggest pieces of the answer deals with slope aspect. We've discussed a little bit about the difference between north-facing, or mesic, and south-facing, or xeric slopes. And we tend to find different life zones occurring at lower elevations on the north-facing mesic slopes and at higher elevations on the south-facing xeric slopes. So if we were to go up Boulder Canyon from Boulder, for instance, we'd start seeing that lower ecotone, that transition from grassland to ponderosa pine, happening more quickly on the north-facing slopes than on the south-facing slopes. And we'd see similar patterns in terms of where we would encounter the transitions between the lower montane and the upper montane and the subalpine, and so forth, all taking place at lower elevation on these mesic slopes than on those xeric slopes. This, however, is a lot less pronounced at timberline. Timberline elevation tends to be a lot more driven by wind and by other climatic factors than those that are strictly governed by elevation. In fact, you'll see lower timberlines in some cases on some of the most exposed, driest ridge lines than you would find on either a north-facing or a south-facing slope. Another piece of this puzzle, as we're getting from looking at the very general to the more specific, is that if you look a little bit more closely beyond just the life zones identified on this chart to some of the species, you'll see that some of these species are behaving in a somewhat frustrating way. Rather than neatly lining up with the life zones we've talked about, they in fact recur. So that, for instance, we might see the ponderosa pine growing not only in the lower montane zone, but also being the major tree species in the lower ecotone, and ponderosa pine being found not infrequently up into the upper montane. We could say something similar about the lodgepole pine. Lodgepole pine are a frequent species in the upper montane zone, but we also find them being dominant in the lower elevations of the subalpine. So just as we see some tree species occurring in multiple life zones, we can also see that some life zones have more than one forest type. So as useful as it is to think about, oh, there are 3 forested life zones, in fact, if we're looking at actual forest communities, we need to be a little bit more specific than that. And another kind of complexity comes from the fact that even within a given life zone, you'll in some cases see species that have specialized in particular environments. So that, for instance, the major tree species of the lower montane zone are the ponderosa pine and the Douglas fir. These are 2 species that from a distance might look pretty similar, but once you've looked at them pretty closely, you'll see that there are in fact some pretty key differences between them. We'll be looking at that in more detail coming up. The important thing I want to note here, though, is that ponderosa pine tend to favor more xeric conditions, drier, more south-facing slopes, whereas Douglas fir tend to prefer more mesic conditions. That seems like a pretty clear distinction if you think about mountains as having a north side and a south side, for instance, though remembering that the north side and the north-facing side aren't always the same thing. However, if you think about a real mountain, uh, there's often a lot more complex terrain and topography involved. So ponderosa pine and Douglas fir can actually grow in pretty close proximity to one another, with the Doug fir being a little bit preferring slightly more mesic conditions, and ponderosa pine preferring slightly more xeric conditions. But if we take all of that together, you start getting a sense of what all is going on in this chart. The next thing that I'd like to do is to take you guys on a little bit of a vacation or a tour of some of these different forested zones. Specifically, I've assembled a tour that has about 8 different stops, and I'll ask you to take a look at that in correspondence with the actual locations where they occur. That, of course, means that one of the best ways of studying some of this isn't just to look at it through the photos and videos that I've prepared for you. Rather, if you get the opportunity, I would strongly encourage you to take a trip up into the mountains for yourself. Now, the opportunities that you have to visit some of the highest parts of Colorado's mountains are a little bit limited. Well, it's pretty easy to get into the lower Ecotone and the lower Montane. Just take a walk a few blocks south of the CU campus up to Chautauqua Park, and even much of the upper Montane and the subalpine are pretty easily accessible. Getting up into the really higher elevations is a lot more difficult. However, I've listed here a number of places where there is in fact seasonal access by road into the high alpine, places like the Trail Ridge Road in Rocky Mountain National Park, the roads up Mount Evans or Pikes Peak if you care to drive your car to the summit of a 14er, Loveland Pass, the two-lane road that serves as an alternate to the tunnel along I-70, or further into the high country, Independence Pass or Cottonwood Pass in the Sawatch Range. Now, depending on when you're watching this, you may find that some of these roads have a tendency to be closed. In fact, just about all of them are closed during the depth of the winter. So if you do want to get out, take a weekend or take a weekday and go on a vegetation tour of your own, I would highly recommend that you check road openings and conditions before you go, that you bring warm clothing, and that even then you go up there prepared to face a little bit of disappointment. It's taken me a couple of drives up Trail Ridge Road before I was able to get even most of the videos, not to say all, that I'd wanted to shoot.